All right, so I hope you guys are enjoying these videos. I really enjoy having a video myself because then I get to start and stop it, pause it, write down things. I always have access to it. Maybe if I'm sick, I can easily do this at home. So I hope you're enjoying having something that's personalized to you. Today we're going to talk about volume, and hopefully you've done volume in math. We're going to talk about the volume of different shapes and how you might take the volume depending on what shape it is. First off, I probably better start out by telling you what volume is. Volume is the amount of space that something takes up. So, however much space a cube or a rock or whatever, how much space it takes up, that is its volume. And we are going to use 2 units for volume in this class. We are going to use centimeters cubed and milliliters. Okay, so I can write that for you. We are going to use centimeters cubed, and we are going to use milliliters. How do you measure volume? Well, we're actually going to talk about 2 ways. We're going to talk about using a ruler to measure, and we're also going to talk about liquid displacement. And we're actually going to talk about measuring 2 different types of shapes. We're going to talk about rectangles and squares because you would measure them differently than you would, say, like a cylinder. So we're going to talk about how would you measure, and then how would you do liquid displacement. And liquid displacement might actually be something new to you. Okay, so let's start out first with liquid displacement. You always use liquid to do liquid displacement. Let's say that you are going to measure the volume of this rock. So you would start out and you would fill up your graduated cylinder with water. Like this one here, the water is yellow or whatever it is they're measuring. And it is about 90 milliliters. That would be the initial volume, would be 90 milliliters. Okay? And then the final volume would be after you place the rock into the graduated cylinder, it's going to move. Okay, now you need to be sure that when you fill up your graduated cylinder to take the initial, that you have enough room so that way the water doesn't overflow. But if once you take the rock and you place it in the graduated cylinder, you're going to have a final volume. Let's just imagine that that final volume is like 100 milliliters. Okay? So then you would just take and you'd plug those numbers into the formula. The final volume minus the initial volume equals the total volume, which here, 100 minus 90 is going to be 10. So the final volume would be 10 milliliters. Okay, that would be our volume. Let's take a look at another way to measure volume. That would be with a ruler. So maybe you're going to have an object that is more rigid in structure, like a box or a cube or a rectangle, rectangular prism, I should say. You might want to use a ruler, and you would do that by measuring length times width times height. Okay. Let's just imagine here if we take and we start measuring at the 0, by the way, let me make a point that some rulers, the very, very end of the ruler is 0. Some of the rulers start 0 a little bit farther in and they have it marked. So just be careful as to where the 0 is, as to where you start. And then you're going to use centimeters to measure the length, the width, and the height. So here, I just want to point out the big numbers on the ruler would be the centimeters, and then the little numbers would be the millimeters. So like for example, if we were to measure where this arrow is pointing to, right here, this arrow, if we were to measure where it's pointing to, it would be 2.4 centimeters. Okay, so that would be where what's being measured as far as that arrow. 2.4 centimeters. Okay. Awesome. So that's just how we use a ruler, a metric ruler, to measure in centimeters. So you will need to, when you get to the lab, you will need to measure the length times the width times the height, and your units will be centimeters times centimeters times centimeters. So when we take volume in science, we always use the unit centimeters cubed. I don't need capitalized centimeters. Centimeters cubed. That's always your unit when you're measuring volume, length times width times height in science. Okay, and this is your first student sheet. You will need to use this as you do the lab. It's really good. It's a really good, helpful sheet. I want to point out a couple things. First off, up here at the top where it says record the letter of your group's cup, that doesn't matter. It does, in a class of our size, it really does not matter. I actually don't have letters on your cups, so don't even worry about it. When you predict the volume, it'll ask you in the procedures to predict the volume least to greatest. And then you actually will go back and you will record what the final volumes were least to greatest, see how close you were, okay? This is a really good helpful sheet because it will tell you the measurements and calculations for a cube or a bar, which I talked about, length times width times height, and it will even show you how to measure it if you read it right there. Then it also shows you how to do it for a cylinder, which I find really cool. A cylinder could be a little bit more challenging. I really like this picture because it talks about here, it says measure the height, you can see the height over here of the cylinder, and measure the diameter. And the diameter is the longest, the widest part of the circle on a cylinder. Okay, that would be the diameter, so you could see it up there at the top. And then you use the diameter to determine the radius, and because the radius is actually what's going to be in your formula. If you look down here at the formula, you don't see diameter, but you do see radius, and the radius is just half of the diameter. So in order to find the radius, you just take the diameter and divide it by 2. Okay, so for a cylinder, the volume equals pi, which if you didn't know, pi is 3.14. That's what we will use in science in this class. Times the radius squared times the height. Now remember, since it's the radius squared in order of operations, remember we talk about please excuse my dear Aunt Sally or PEMDAS. When we talk about that, we talk about how parentheses come first, followed by exponents, and the radius squared is an exponent. So when you are doing your math for this, you have to do the radius squared first. Okay, so it would be 3.14, you'd plug in the radius squared times the height, and you would take the radius squared first. That would be the first thing that you would do. And then you would just multiply the rest of the numbers out to find your final volume. Again, the measurement for this, for cylinder, you're going to get centimeters cubed, since we will be measuring in centimeters. And then last but certainly not least, down here there is water displacement. This is how you would do the liquid displacement, how I talked about taking the final volume minus the initial volume. So use this sheet as you do this activity. It will really help you in how to determine the volume of each separate type of solid. Good luck.